Okay, welcome back. This is question number 6, the final question on this paper of June 2021 of the International A-Level Edexcel Statistics S1 exam. This question here is about correlation and regression. Two economic students, Andy and Behrouz, are studying some data related to unemployment, which is denoted as X%, and increase in wages, Y%, for a European country. The least squares regression line of y and x has equation y equals 3.684 minus 0.3242x. And then they give us some data, the sum of the y values, and then the sum of the squares of the y values, the sum of the squares of the x values, and the number of entries that are given to us. We have to show that SYY equals 7.524375. Many students have no idea what any of this means, yet they can get almost full marks in a question like this by just looking at the formula book, right? And they'll see the formula given to you on this topic, and they'll just figure out what goes where, and they manage to get through the question without actually understanding a single thing about what this actually means. Of course, that's not ideal. So just to give you an idea of what it means, I'm going to give you a little introduction. So basically, this topic of correlation and regression is to do with when you want to study how one thing affects something else. Is there some relationship between something and something else? For example, here, between unemployment and increase in wages. So does the increase in wages affect unemployment? That's what this is about. It says the regression line of y on x. Y on x, the effect of y on x, the effect of the increase of wages on unemployment is given by this formula here. So what's happened is, basically, they had some x values and they had some y values. The x values here represent the unemployment rate, and the y values represent the increase in wages. Okay, and they have 16 data entries. Okay, and they plot on a pair of axes those data entries. Okay, so you have a pair of axes. You have your x and your y axis. Here, your y axis is representing your increase in wages. So this represents the wages increase. So this is wages, and the x value represents the unemployment rate, the rate that people don't have work. Okay, so that's what those represent. And they plotted these data points. Okay, they plotted 16 data points, and they have drawn a line through those data points, okay, in such a way that it minimizes the distance between each point and the line. That's called the line of best fit. That's what this represents. This represents the line that fits through those data points in such a way that the average distance of the points from the line is as small as possible. So it's called the line of best fit. In IGCSE, you would draw that by looking and trying to fit it through so that there's an equal number of points above and below, and it follows the gradient of the line. In AS, we actually work out the equation of the line of best fit using the formulae given. We don't really have to understand how those formulae give the line of best fit. We don't have to understand the maths behind that, but we just have to understand that formula will give us the line of best fit with this data. That's all we need to know. Okay, so they've got the equation of the line of best fit. I've drawn it with a negative gradient because I can see that this is y equals like the gradient times x, mx plus c. So this kind of represents the gradient of the line. We can see it's going to have negative correlation, meaning we can see that when the increase in wages is high, okay, the unemployment rate is low. When the increase in wages is low, the unemployment rate is high. Okay, as the wages decrease, okay, the rate of unemployment increases. As the wages increase, the rate of unemployment decreases. That's what this data shows. This is according to the data given here. So first of all, it says show that SYY equals 7.524375. So what does SYY mean? Well, basically what it means is it's a measure of the variation of y, okay, the y values with themselves. So basically, it's how far spread apart these y values are. It's an average spread of these y values from the mean of the y values. How a measure of how spread apart the y values are. That's what it means, basically. Okay, it's a measure of that. So that's what that means. How do we find it? Well, we can go to the formula book, and we can see there's a formula here saying SYY equals, and this is the sum of the square of all the y values minus the sum of the y values then squared over n. Okay, so that formula will help us. So if we go back here and we dig up that formula over here, all right, so that's just taken straight from the formula book. We can see we have these, from this part, we have these pieces of information that we need. Okay, we have this here, and that's the formula that we're going to need, right? So if we see, we have the sum of y squared, which is this here. Okay, so as I said, some people will answer this question without knowing what anything means, and they'll say, okay, that's the same as that, so they'll say 42.63 minus, okay, now this is the sum of y, then all squared. So it's not this, okay, it's this thing here, but all squared. See the difference between this and this? Here we have the y values all added together. Here we have the y values, they're squared first, so you square this, then you square this, and you square that, then you square that, then you square that, then you add them together. That's the difference between these two things. All right, if you square this, so this is going to be 23.7 all squared divided by n, which is the number of entries, which is 16. Now that should give us the answer required. Okay, so we have 42.63 minus 23.7, it's just the numerator squared, over 16. Okay, and that gives us, hopefully, exactly what we're supposed to give us, which is 7.524375. Yes, it does. So it gives us exactly the same thing, 7.524375. So we've done part A just by simply pulling up this formula from the formula book and applying these numbers into that formula. So that's part A done. Now we're going to go into part B. Okay, so for part B, we're told to find SXX. Now we know this information here. Okay, we know the equation of the regression line. We have this information. Now, the formula for SXX is very similar to this formula. Okay, again, we can get it from the formula book. And this is it. If we go back to the formula book, this is actually the formula that we need. Now, this formula here, okay, is, very similar to this one, except it just involves x. So it just tells us how all the x values, okay, are spread apart from the mean. Variation. This is a measure of the variation of the x values. Okay, but the problem is here is we have the sum of x squared. Okay, so we know the sum of x squared, which is 756.81. Okay, but the problem is we don't have the sum of x. We have n. We need to find the sum of x, and then we can find SXX. Right? We need the sum of x. How are we going to find the sum of x? Well, again, if we look at our formula book, we can see what we do have here is the regression line. Okay, the equation of the regression line of y on x. We have that. And if you see the equation of the regression line of y on x is given by this formula, y equals a plus bx. And you can see inside this formula, there is x bar. Now, x bar means the sum of x divided by n. That's what x bar is. It means the mean of the x values. So all those x values, it's the sum of them divided by the number of entries. That's what x bar means, the mean of the x values. So this is the mean of the y values. This is the mean of the x values. I can find both of these. Okay, I can't find this directly. I can find the mean of the y values because I have the sum of the y values, and there's 16 values. I know what that is. And a and b are basically just the gradient and the y-intercept of the equation of the line, and I have the equation of the line. So I have A, I have B, and I can find y bar. So if I have A and I have B and I can find y bar, the only thing remaining is we need to find x bar. Once I've found x bar, I can find the sum of x by multiplying the number of entries by x bar. So this formula here, or these formulae here, will be something very useful for us to have. So let me just go back here. And let's go to, 1 second, that was there. Let's go back down. We have some of the x values. We have also some other formula here. This one, the least squares regression line of y and x. That's what we just mentioned here. So we know that from this line, okay, we have y equals 3.684 minus 0.3242x. Be very careful when you copy the numbers down. It's very easy in this topic to make a mistake of of copying numbers incorrectly. Okay, so we can see that A from this formula is 3.684. And we can see that B is negative 0.3242. Okay, so I have A and B from this formula, and I can find what y bar is because I know the sum of y. So y bar, which is the mean of y, is the sum of y. Okay, the sum of y over the number of entries, which is equal to 23.7, sum of y, divided by the number of entries, which is 16. So that's y bar. Okay, if that doesn't give me an exact value, I'll use it as a fraction, as a fraction like this, divided by 16. Okay, so I can leave it like this for now and work out its value later. All right, so that's y bar. So now what I need to do is find what x bar is. I know A, I know y bar, I know B. So I can say that x bar, I can say A, which is using this formula 3.684. This is A equals y bar, which is equal to 23.7 over 16. Minus B, which is 0.3242 times x bar. So I can find the y bar minus bx. Okay, so this is actually minus, and that's a minus as well. Be very careful here, because our b is negative. So this is minus b, so it's minus b here. Okay, so be very minus this value because the b is a negative value. That's a place where you could make a mistake there. And we can now solve this equation. We can basically say this is going to be positive now. So you'll end up with, this will become a positive. So when you move it to this side, or you add it to both sides, you're going to, or subtract it from both sides, you're going to get 0.3242x bar equals 23.7 over 16 minus 3.684. So we can now, that's going to be negative, as I said, because it's positive here, so it'll be negative. So now I can find what x bar is by subtracting these. So I have this, which is 23.7 divided by 16, minus 3.684. Okay, which gives us negative, well, let me just find that. Divide that by negative 0.3242, and that gives us 6.79441. 6.79441. Okay, how many decimal places they want it to? Okay, so they didn't mention, so we're going to write it to 3SF, which is 6.79. Well, that's not our final answer, sorry. Leave it like this for now, in its exact form. We want to find, yeah, so sorry, that wasn't the final answer. That was just x bar, okay? So we're trying to find, remember, SXX. Okay, so to find SXX, we're going to use the formula that we're given here, which is the sum of x squared. So we need to find the sum of x squared. Right, how do we find the sum of x squared? So we need to find the sum of x. Okay, so the sum of x, okay, is basically divided by 16 gives us the mean of x. Okay, the mean of x. So we know the mean of x, so the sum of x is equal to 16 times the mean of x. So we take this answer we got and we multiply it by 16. And that gives us a sum of x, which is 108.71. 108.71. Okay, I'll just write it a few more decimal places, 0.67. Okay, that's the sum of x. So now we can use our formula over here, which is the sum of x squared, which we already know, which is 756.81. So SXX is equal to 756.81 minus, and then we got the sum of x squared, sum of x all squared. Okay, as we can see here, the sum of x all squared divided by 16. So that's what we just found here. The sum of x is basically 108.71067 and squared and divided by 16, and that should give us what we're looking for. So we're going to take this and we're going to square it. Okay, we're going to divide it by 16. Okay, and then we're going to do 756.81 minus the answer. Take away our answer, and then that gives us 18.18.18435. 18.18435 continues on. So to 3SF, that's 18.2. That's SXX. So that's the answer to part B of that question. Okay, now for part C, it says find the product moment correlation coefficient, which is known as Pmcc, between X and Y. And what that means is it's basically a measure of how close the points lie to a straight line. Okay, how closely the points lie close to the straight line. So the Pmcc, the closer it is to 1 or -1, means the more perfect the correlation, the more they are in line with each other, all the points. And the more they are in line with each other, the closer they are to the straight line. Either if it's positive or -1, means the stronger the correlation. Okay, the stronger the relationship that we find between them. Okay, so if Pmcc is 1, it's perfect positive correlation. If it's a -1, it's perfect negative correlation. If it's closer to 0, either negative or positive, means the points are more spread out everywhere. So positive correlation, perfect, will be almost a straight line. Negative, almost a straight line, but the negative side. And correlation, which is weak, the points will be kind of spread out. Okay, so that's what Pmcc is. A measure of how closely together the points line up in a straight line, and it also tells us whether it's a positive or negative correlation. Okay, so now the Pmcc, again, it's something that we can find from the formula book. Okay, and if you go back to the formula book, we can see here that it says a product moment correlation coefficient is given by, and it has R equals, and you've got these 3 different formulae that we can use. Well, this is probably the easiest form of the formula to use. SXY over the square root of SXX SYY. Okay, that's what we're going to use, that particular formula. So we go back to here. That's the formula I've just copied across. So now we need to know what SXX is, which we just found as 18.2, but I'll write it in a more accurate form, which is 18.18435 ... and SYY, which we found and were asked to give to this decimal place, is 7.524375. 7.524375. That's SYY. Now we need SXY. Now we weren't given SXY. Okay, so we weren't given SXY. So if we find what SXY is, we can answer this question. So that's our mission now, to find SXY. So if we go back again, okay, we can see SXY is equal to the sum of X and Y, all right, minus, it's X times Y, minus the sum of X times the sum of Y over N. Now I found these two, but I don't know what this is. I don't know what the sum of all the X and Y product of the X values is, and I don't think I can find it from this directly. So we've got to think of somewhere else we can see SXY, and I can see it over here, in this formula over here. B, which we know, which was, remember, the coefficient of X in the formula, and SXX, which we already found in just now. All right, those two, we know both of them now, so we can find it using this formula. So that's what you got to do in this type of topic. Go switch from formula to formula to see what you can use to find what you need. Okay, so let's take that formula that we just looked at. All right, so as I said, we know what B is. Okay, we know what SXX is, and we know what S. We can find this now. So this is going to be B times SXX. So SXY is going to be B, which we already found as minus 0.3242. We just read it off the equation of the line, minus 0.3242. That's negative 0.3242 times SXX, which we just found here. So I'll write it in its more accurate form, 18.18435, and I can just multiply them together. So I've got my answer. I'll just multiply it by the value of B, so times negative 0.3242, and that gives us our answer as minus 5.8985. Minus 5, is that right for B? Yeah, that's right. So that gives us our answer, as I said, minus 5.8953 minus 5.8953, which to 3SF is minus 5. You can say 90. Okay, so that's SXY. All right, that's not our answer though, by the way. Keep writing that as my answer. That's SXY. We got to find what R is. Okay, so I'll just fit it in at the bottom here. So R, remember, is SXY, which we just found, which is minus 5.8953, okay, divided by the square root of SXX, which is 18.18435, multiplied by SYY, which is 7.524375. So if I put that into my calculator, so I have this value here, which is what we just found there, divided by, and I'm going to put in brackets the square root of 18.18435, okay, multiplied by 7.524375. Close that bracket there, and that gives us, oops, what did I do there? I closed the bracket too early. 1 second. You have to put that press out of the bracket and then out of the square root sign, and then put the bracket and press equals. You get negative 0.50399, negative 0.5039997, whatever, 9957, sorry. Okay, we don't need all of those. I'm going to write that to 3SF, which is negative 0.504. That's the value of R, the Pmcc between X and Y. So that's the answer to part C. Okay, now for part D. It says Behrouz claims that assuming the model is valid, the data show that when unemployment is 2%, wages increase at over 3%. Explain how Behrouz could have come to this conclusion. Okay, so let's take the equation of the line of best fit. Basically, what they could have done, remember, it was how the wages, increase in wages affect unemployment. This is the wages, and this is unemployment. Okay, so you could have come, maybe, let's see what happens when you put these values into the equation. So when the increase in wages is 2%, when the unemployment is 2%, wages increase over 3%. So that means when X equals 2, okay, then it says Y is going to be over 3. Let's see if that actually is borne out by the equation. So you say 3.684 minus 0.3242 times X, which is 2. Let's see what that gives us. Stick that in the calculator. So you have 3.684 minus 0.3242 times 2. What does that give us? It gives us 3.0356. 3.0356. Okay, so Behrouz used the regression line formula. Use the regression line formula to come to this conclusion. Okay, that when the wages increase at when the unemployment rate increases by 2%, the wages increase by 3%. That's what this equation tells us. So that's how Behrouz could have come to this conclusion. Then it says Andy uses the formula, the range is equal to the mean plus or minus 3 times the standard deviation to estimate the range of values of X. Find the estimates and the minimum value and the maximum value of X in these data find the estimate, of the minimum and the maximum value of the X in these data using Andy's formula. Okay, so basically we need for X, we need to find the mean, and we need to find the standard deviation for X. Okay, if we know the mean of X and the standard deviation, we can find the maximum and the minimum value. All right, so we need to know some data about x. So we need to know the sum of x. We also need to know the sum of x squared. Okay, the sum of the squares of the values of x. We need to know the number of entries, which is 16. So all of this data, I think, is given. Let's take it from the last page. So we have the sum of x squared. We already have is 756.81. That's something we already worked out, 756.81. And the sum of x we worked out also. The sum of the x values we worked out as, where was it? Okay, it was 6.7944, 6.7944. Those were the sum of the x values. 6.7944. Was that right? Just make sure. Sum of the x values, yeah, 6.7. Oh, that was the mean of the x value. The sum of the x values was 108.7106. 108. Sorry about this, guys. 108.7106. So be very careful about this. Okay, 108.71. All right. So that's not the sum of x. This is the sum of x. 108.71. Okay, continue on, but that's enough for us. So that's the sum of the x values. The sum of the x squared values, the number of terms. So the mean is pretty simple. The mean is what we actually already found it. It's just that divided by 16, which was, that was what I wrote down before, 6.79441. 6.79441. That's 6.79441. That's the mean. Okay, and we need to find the standard deviation. Now the standard deviation is the square root of the variance, and the variance is the mean of the squares minus the square of the mean. The mean of the squares means the sum of all the squares of x value divided by, okay, n, minus the square of the mean, which is the sum of x squared, okay, the sum of the, sorry, the sum of, it's basically the mean squared, which is the sum of all the x values divided by n, and that all squared, the square of the mean. The mean of the squares minus the square of the mean. All right, so that's going to be equal to the standard deviation, okay, is going to be the sum of, okay, so you got the sum of x squared, which you already have, which is 756.81 divided by 16 minus the mean squared, which is the square of the mean squared, which is 6.79441, and that will give us the standard deviation. Okay, this is squared, sorry. The mean of the squares minus the square of the mean, so you square that. So you got here 756.81 divided by 16. Then take away 6.799441 and square that. Okay, and then we take the square root of our answer, and we end up with 1.0661. 1.0661. That's the standard deviation. So Andy's formula is that the range, okay, I'm just going to make a bit of space here and continue down here. So the range formula is that the range equals the mean plus or minus 3 times the standard deviation. Okay, so this is the standard deviation. Okay, sigma. So the mean we already found. The mean is 6.79441 plus or minus 3 times the standard deviation, which is 1.0661. So we can say that find the all right, so find estimates for the minimum value and the maximum. So we can say the minimum value is going to be when you subtract these. So you have 6.79441, okay, minus 3 times 1.0661. That gives you 3.596. So 3.596 continues on. That's a minimum value. which is equal to 3.60 to 3SF. Does it say accurate to write it? No. And then the maximum value is going to be when you add. So I can just go back here and change that minus to a plus. And that gives us 9.99, 9.992, which is 9.99. So that's a minimum value and that's a maximum value, and that's part E done. Okay, so now part F says, comment giving a reason on the reliability of Behrouz's claim. What claim? Obviously this claim. Okay, Behrouz claims that assuming the model is valid, the data shows that when unemployment is 2%, wages increase at over 3%. Now remember the unemployment is 2%, that's Y, and wages is X. Okay, so wages is X. Sorry, what was it again? One second. Okay, unemployment is X, sorry, and wages is Y. Unemployment is X and wages is Y. That's right. Okay, sorry about that. Just got mixed up for a second. So wages is Y, unemployment is X. Okay, so X is the unemployment rate. So it's saying when unemployment is 2%, wages increase at over 3%. So the unemployment he's mentioned here is a value of 2. That's X value of 2. Now, as you can see here, it says that the maximum value and the minimum value of X in these data, okay, is going to be between 3.6 up to 9.99. So X equals 2. So we can say the range of X values in the data, the range of X values in the data is between the values, as you mentioned here, 3.6 to 3.60, sorry, to 9.99. Okay, so X equals 2, which is what Behrouz is basing the claim on, when X equals 2, Y equals 3. X equals 2 is considered extrapolation. Extrapolation means it's a data value that's not within the range of our data, therefore unreliable. Okay, it's outside of the range of the data. Our data starts from 3.6 up to 9.99. This data value 2 shouldn't be used in there because we don't know how it will affect it. We only know about this range of values. Okay, so something like that should be fine, except with better handwriting than mine. Sorry about that. Okay, so we can say, let me just move this table. Okay, so therefore we can say unreliable. Okay, so that's how we can say for F. Then it says, Andy suggests using the regression line with the equation y equals 3.684 minus 0.3242x, which is the one we found, to estimate unemployment when wages are increasing at 2%. So this is, remember, unemployment is X and wages is, okay, Y. So if we want to use this, this regression line is used when we know the unemployment rate, okay, and we're trying to find the wages. Y on X, this is the input, that is the output. Okay, so we can say that this is going to be not sensible, okay, because we need the regression line, okay, because we would need to be accurate, okay, the line of X on Y, okay, of X on Y. Okay, so you can estimate with this. You can estimate the wages when given the unemployment. Okay, you can estimate the wages given the unemployment. Okay, we need to have X equals some function of Y to estimate the unemployment given the wages. All right. So when we are trying to estimate the unemployment when we're given the wages, we need the regression line of X on Y, not Y on X. okay, because we need unemployment as the subject, and then we need, A plus bx. We need by, we need y to be the part which is inside the formula. This is x on y, so you can estimate x given y. Here you can estimate y, which is wages given the employment. We need the equation like this, x, where y is inside the formula, so we can work out the unemployment given the wages. Okay, and it's not a simple case of just rearranging this formula like, in any way. You have to make a line of best fit for that. You have to find an equation for that separately. Okay, so that's the answer for part G, and I think that's the end of the question and the end of the paper. I hope that was clear. As I said, this last topic, a lot of students don't really understand what a lot of these things are, yet they still manage to get most of the marks just by, looking at the formulae. But anyway, there's the end, and thank you for watching. Other questions from this S1 paper can be found by clicking the link that should appear in this area at the end of the video. Other questions about correlation and regression from S1 can be found by clicking this link. You can subscribe to my channel by clicking over here, and if you look in the description of the video, you will find links taking you to the other papers that you might want to watch: P1, P2, P3, P4, M1, and also some IGCSE papers, mainly from the Cambridge board. Thank you for watching, and see you soon.